Hi guys, today we're going to be talking about angle relationships within circles. Let's start off with our first theorem that we're going to learn today, which is the tangent and intersected chord theorem. So this theorem states that if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So if you look at this example, if we wanted to find angle 1, we know that its intercepted arc is going to be arc AB, right? So angle 1 would be 1/2 of AB. Similarly, if we look at angle 2, that would be half of BCA, right? So let's pretend that BCA was, 200 degrees. Then angle 2 would be 100 degrees, okay? So let's do some examples here. So if we look at example 1, in example 1, it says line M is tangent to the circle. Find the measure of the red angle or arc, okay? So for question A, we're given that we have a chord AB and then we have our tangent M, right? We're trying to find angle 1. Now, if we look at its intercepted arc, the intercepted arc is 130 degrees. So 1 would simply be, so measure of angle 1 would simply be 1/2 of 130 degrees, which would be 65 degrees, okay? Now, if we look at B, the intercepted arc here would be KJL, right? So if we know that KJL, if we're trying to find KJL and we're given the measure of the angle that's created with the chord and the tangent, we're told that that angle is 125 degrees. So in order to find it, this time, in order to find the measure of the intercepted arc, we would have to multiply by 2. So then the measure of arc KJL would be 2 times 125. And this would be 250 degrees, okay? So it's the opposite of what we were doing at first. At first, we were given the intercepted arc and we were trying to find the angle. This time we were given the angle and we were trying to find. Okay, so let's look at example 2 now. In example 2, let's say that we were given a circle, all right, and we were given chords within that circle that intersect, okay? Now, those chords are going to form angles. The angles inside a circle theorem basically shows us how to find those angles. So it states that if two chords intersect inside of a triangle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. All right, so that's kind of a mouthful. If we look at the measure of angle 1 in this example, that's going to be 1/2 of DC, which is this angle, which is this arc here, plus AB. So we're going to look at the two arcs, right? The two arcs that's created by the angle, and then we're going to just divide it by 2, and that's going to give us the measure of angle 1. Now, if we know the measure of angle 1, then we also know the vertical angle across from it as well, right? Now, if we were looking at measure of angle 2, then that would be the measure of arc AD plus the measure of arc BD divided by 2, all right? So, in other words, you're going to do the arc plus the arc, and then you're going to divide it by 2. Okay, so let's look at example A. In this case, the arcs that correspond with angle X would be the arc JM and arc KL. So I'm going to add those two arcs together, right? So I'm going to do 130 plus 156, and then I'm going to divide it by 2 to find measure of angle X, right? So when I do that, I get X is equal to 143. Okay, so in this next one, let's say that you have angles outside of a circle, all right? In order to find the angle measures, you're going to use the angles outside of a circle theorem. This basically states that if you have a tangent and a secant, or if you have two tangents, or if you have two secants that intersect outside of a circle, just like those examples shown, then the measure of the angle formed is going to be 1/2 the difference of the measures of the intercepted arcs, right? So in the first example that we did with angles inside of a circle, it was the sum of the two arcs divided by 2. In this case, it's going to be the difference of the two arcs divided by 2. Now, it doesn't matter if you have a secant and a tangent like the first one, or if you have two tangents, or if you have two secants. The method is exactly the same. You're always going to do the outer arc minus the inner arc, and then you're going to divide it by 2 in order to get that outer angle 1, okay? In this case, you're doing the same thing. You're doing the outer arc minus the inner arc, and then divide it by 2 to get that angle 2. Over here, same thing. You have two secants this time, but it's still done the same exact way. Outer arc minus the inner arc divided by 2 to give you angle 3. So it's pretty simple. So you would just do arc minus arc divided by 2, no matter what type of situation you have. If you have if you have either tangents or secants or a combination of the two, and it creates an angle outside of the circle, that's always going to be the format that you're going to use. So if you look at this example, we have one tangent and we have one secant, and it does create an angle outside of the circle, right? That angle here is x. So in order to find angle x, you're going to do the same thing. So you're going to do 178 minus 76 divided by 2, and that's going to give you your x value. When you plug that into the calculator, you get x equals 51 degrees. Okay, so for this next theorem, we're going to talk about the circumscribed angle theorem. This theorem states that the measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the same arc. Okay, so if I look at this example, my angle ADB circumscribes the arc AB, okay? So if we look at this angle, in order to find angle ADB, we would simply subtract, we would do 180 minus the measure of the arc. So in this case, the arc that it intercepts is going to be ACB. So I'm going to do 180 minus angle ACB. All right, let's look at this example A. So for example A, we are given that the circumscribed angle is ADB. So ADB, in order to find measure of ADB, we are simply going to subtract it. We are simply going to subtract the central angle, which in this case the central angle would be ACB, right? So I'm going to do 180 minus 135, and I'm going to get that x, in this case, is going to be 45 degrees. All right, so it's pretty simple. All you're doing is subtracting it from 180. Now, if I look at example B, this one's a little bit more complicated. There's a few more steps involved because this time you're given an inscribed angle, right? You have an inscribed angle and also you have a circumscribed angle. The first thing that you would want to do in this situation is you would want to actually start by drawing your central angle. It's a really bad angle, but that's okay. Now, if you were to do this, then you have your circumscribed angle is 30. You can find your inscribed angle by subtracting 30 from 180, right? Using the circumscribed angle theorem. So if we do 180 minus 30 degrees, that's going to give us 150 degrees, right? So if I know that, that the measure of FGE, or in other words, the central angle, is 150 degrees, FGE, yes. If angle FGE is 150 degrees, then I also know that the measure of the arc, EF, is also 150 degrees. So then all you would do next is just do what you already know about inscribed angles, right? So in order to do that, you're just going to do measure of angle X is going to be just 1/2 of your arc, right? So the arc here is EF. We know that the arc length is 150, so you're just going to do 1/2 times 150 degrees, and then you would get that angle X would be 75 degrees.
I prefer